Hey y'all, what's going on? Okay, I'm just kidding. So we have a math problem here. Given the squares in each figure can be modeled. Okay, wait. It makes a sound when I move the camera. Given the squares in each figure can be modeled by a quadratic equation, ax squared plus bx plus c equals the amount of squares, where x is the figure number in this equation. Solve the equation. So here, there's a bunch of things you can do. So first, I think the most general method is just to turn this into a data table. So right here we have f, which is figure number, sure, and then s, which is the amount of squares. Let's just name this x and y, you know. And so we're figure 1, figure 2, and figure 3. So this has what? 6 plus 2 is 8 squares. This has 3 times 4, 12 plus 2 is 14 squares. This has 4 times 5, 20 plus 2 is 22 squares. Okay, so we have this data table, and right here we can, because these three are all points that are next to each other, like the x's are one by one by one. They're consecutive points, which means we can do this thing where we find the difference between each of these. So this one is 14 minus 8 is 6. This one is an 8. And then we find the second difference, which is 2 right here, because 6 to 8 is 2. So now that we found the second difference, the second difference of any quadratic formula, we're given it's quadratic, ax squared plus bx plus c. Any second difference of a quadratic equation is always constant, so the second difference is always going to be 2. The first difference grows, 6, 8, it'll be 10 next, but second difference stays same. So anyways, now that we have the second difference, there's a rule. I'll prove it at the end of this video, but basically, the second difference of a quadratic equation is equal to 2a. And so basically, we found the second difference here because we have 3 consecutive points. That lets us find the second difference, and we can use this rule right here. The second difference of a quadratic equation is equal to 2a. So if 2 is equal to 2 times a, then right here, in this case right here, our a is equal to 1. So we found the second difference. 2 is equal to 2a. A is equal to 1. So now that we know that a is equal to 1, we have that this equation is in the form x squared, because a is 1, so it doesn't do anything in front of the x squared. X squared plus bx plus c equals squares. And then, yep. So first, then we can just start plugging in values. So we plug in the 1. So 1 squared is 1 plus 1b, b times 1, and then plus c. There's a mess in the background. Okay. Is equal to 8. Now this part is a bit, okay, this seems like a bit of a jump. So basically, you plug in the x and you get the y. So we have ax squared plus bx plus c equals to squares. Right here, when it's 1, when x is equal to 1, squares is equal to 8, and we prove that a is equal to 1. So this is 1 plus just b, because we plug in 1. So 1 squared plus b times 1 plus c is 8. So b plus c is 8. Or, okay, no. So we have b is equal to 7 minus c, okay? Okay, wait, so we have c is equal to, you subtract 1 from both sides, you subtract b from both sides, 7 minus b. Now, this doesn't seem, like, it seems confusing at first, we'll get back to it. Or, you don't have to do this first, but anyhow, the next point we plug in is 2, 14. So 2 squared, if x is 2, then squares is 14, so 2 squared plus 2b plus c is 14. Now, if you solve for this one for c, Now you can see why we did the one above for C, maybe, because we can find B this way, because C is equal to subtract 4 and subtract 2B, so it is 10 minus 2B. So now we have something. Both of these are equal to C, which means that we can set them equal to each other, because if they're both equal to C, they themselves are both equal. So 7 minus B is equal to 10 minus 2B. And right here, you add 2B to both sides just to make B positive. So B, and then you subtract 7 from both sides just to make the 7 go away. B is 3, okay? So now we have the formula is x squared plus 3x plus c. And let's just quickly, yeah. So for c, we know that c is 7 minus b, and we know b is 3, so 7 minus 3 is 4, so we have c is 4. So at the end, the equation is x squared plus 3x plus 4 is the amount of squares every figure. And that is the entire equation, so let's test it. So we plug in 1 squared plus 3 plus 4 is 8. So the first figure is correct. And then the figure 2 is 3 times 4. Wait, so the figure 2 is 2 squared. 4 plus 3 times 2 is 6, which is plus 4, which is 14, yeah. And then finally figure 3, 9 plus 9 plus 4, 18 plus 4 is 22. So it satisfies all these figures, and it will satisfy all the rest of them. Okay, so to move on to another part, we kind of just took this, the second difference of a quadratic equation is equal to 2a. We took this for granted, but we can prove it right here. So first, okay, this is kind of just going over. You can just memorize that fact, and you don't have to watch the rest of this, but you know, just in case. So first, you have any quadratic equation, ax squared plus bx plus c equals y. And so now the we can make a table of inserting x's. So we build a table again where this side is x and this side is y. So right here we have, I'm going to type because this is messy. Ax squared plus bx plus c is, okay, so right here, let's just have x is 1. Okay, I didn't have to type just to do a 1, but whatever. X is 1, then y is equal to, you plug in x is 1, a plus b plus c. Because x is 1, so everything just gets multiplied to 1. Okay, and now next, well, let's get a 2, 3, okay, yeah, there. Just a 2 and a 3. So then y right here becomes a times 2 squared, so 4a plus 2b plus c, right? And then for 3, it becomes 3 squared, so 9a plus 3b plus c. Okay, very cool. We have all this on the table. Tables for quadratic equations are very useful. So now, let's find the first difference of these, because we're trying to prove what we're trying to find something that the second difference always is. So the first difference, let's see, what is the difference here? It is 3a plus b. Yeah, that's how much it changed. Now, what is the difference here? It is 5a plus b. So the first difference is 3a plus b and 5a plus b. It is changing because it's quadratic. The first difference is going to keep increasing or decreasing. Now, what is the second difference of this? The second difference is just 2a. And that's how you prove it. So if we go back to what we said here, the second difference of a quadratic equation is equal to 2a because, for literally any ax squared plus bx plus c is equal to a y, then the second difference is always going to be equal to 2a. As long as these are consecutive, 1, 2, 3, or 2, 3, 4, whatever, next to each other, if you find the second difference of them, it will be 2a. And that's the numerical way of solving this. And just to recap quickly, very fast, the graph way, if you just want to leave it easier, it won't always work even, I don't think, but you can see right here, oh, you want to notice like a pattern in each of these. So you want to look for squares and extra strips. That's how you do these usually, by just looking at them. So you see this square here, it's a 2 by 2. You see an extra 2, that's the same extra 2 in all of them. And then you see an extra strip, that's the same strip in all of them. So it's a square, which is the figure number plus 1 squared, because this is 2 squared and the figure number is 1, so, and this is 3 squared, but the figure number is 2. So this is the big square, and then the strip is always the strip is always the size of the figure number plus 1. And finally, there's just an extra 2 added on. And if you multiply this all out, okay, a plus b squared is a squared plus 2ab plus b squared, x squared plus 2x plus 1 plus x plus 1 plus 2. This becomes x squared plus 3x plus 4. Oh, this gets messy. Okay, well, just like what we got down here, x squared plus 3x plus 4. So 2 methods to solve this, and it should be x squared plus 3x plus 4. So the equation is solved, and that is it. Some cool math concepts here. I just, like, remembered after searching and stuff. It's been a while. Okay, then hope that helps, and bye.